My name's Trevor Morris. I'm with, I work for Machine Metrics. I do back-end programming there. Today I'll be talking about Kinesis, Lambda, DynamoDB, and Athena, all of which are part of Amazon's serverless computing platform. So what we'll be doing, I just had to reboot, so I lost a little bit of context here, which I can quickly bring back up. We will have, can you see this this okay? Yeah, good. Let's see. For some reason, it's supposed to be on both the right and the left, but I guess we'll only get it on one side, which is fine. So I don't want to lose it. I'll just have to do that. Yeah, so you'll only get it on one side. So we'll talk about this in more detail, exactly what this little application is doing. We have a little node application called Gather, which we will run. And this is going to gather metrics off of my laptop, ship it to AWS, to Kinesis, which will then fire off Lambda functions, which then store the data into DynamoDB. And then we can just go to Dynamo. And of course, I've lost a little bit of context here because I had to reboot. There was some, there we go. Some technical problems getting the screens working, which of course rebooting my laptop managed to resolve. So then at the end of the talk, we'll be able to see that, in fact, we have this table, which is called Trevor Talk Metrics, and we can see that we've loaded the metrics that are being sent from my laptop into the database over here, which we can see right here. We'll also be able to see the data over in Athena, which is a different database used for different ways. And we'll get to the details of why you might want to use Athena versus DynamoDB. And whoops. We can say preview the table, and we'll see that we have, after a few seconds here, some data with the various load, how much memory is free and available disk on my computer. And with a timestamp, I've been sending it periodically over the last day or so. So let's step back a little bit. That's a high-level overview of what we're going to be doing. We'll be sending metrics from my computer up to the cloud and storing them in a couple of different databases. How we're going to do that is initially we send the data to Kinesis. Kinesis is a streaming platform that where you send the data, and it's similar to a message queue, but instead of being a queue, you think of it like a conveyor belt. So we put the data onto the conveyor belt, and it travels along for up to 24 hours. All Kinesis streams can, by default, are 24 hours long. So you put your data on there, and it's available for 24 hours. Then you can have an observer go look at the conveyor belt and pick the data off at any point along the stream. So let's go over to Kinesis, and how would we create a Kinesis stream? We go to data stream, say create Kinesis stream. We'll call this our sample stream. So each stream also has a number of shards because there's a limit of how much data you can push into the stream at any given time. We'll just start with one shard because I'm only sending from one computer. Create the Kinesis stream, which I've already done. over here with the talk metrics. And that's where the data is getting sent from this application that I just started over here. It's getting sent into this talk metric stream. Let's have a look at that application that's sending the data up to Kinesis. I've got it broken down into 4 different steps here. It's called the gather application. This initial diff, I'm going to very quickly go over, gloss over, because it's simply framework code that's not particularly interesting. And we'll skip to the second set, which is code that actually gathers the metrics. And this is all just a node application running locally on my computer. And you can see it calls into the operating system. Here we actually invoke Docker to get the available memory on the system because it was an easy way to get available memory. We just call into the OS to get the load averages and free mem. Then we have just a hash or a JavaScript object of the various metrics and their values. So we create that in this initial, in this snapshot, we just say push metrics, we'll log that to the console. So this doesn't use Kinesis yet. This is just the next step in how I wrote the application, gathering these metrics up off of the computer and then logging them to the console. So the next step is where we get to the most interesting part, is how do we then send this data we're collecting on my computer up to Amazon and Kinesis. And this is actually fairly straightforward. One of the first things, of course, we're going to do is include the AWS SDK. There are a number of different programming languages where Amazon provides their SDK for. If you're doing AWS development, you're probably going to be using one of these SDKs. And then we go down here, and the same push metrics application or function, which used to just log to the console, now puts the data into the format required by Kinesis, which is a JavaScript object. Isn't that Kinesis requires a JavaScript object, but the SDK takes a JavaScript object, then packages up in a format that is actually an HTTP request to AWS with the data in the specific format where you have a data, a segment, and then a partition key, which is just the metric user. And then this 3 lines of code set calls put record on those records for the stream, which, if you recall, is talk metrics. We're using promises, and then once it's been sent, we just log to the console that these records were sent. And you can see that's what's happening here in the background. The records are being sent up to Kinesis. Now, again, you can think of this as Kinesis is a conveyor belt up there, and now it's filling up with little data packets. I send 1 metric per data packet. So each time this runs, we've got 5 records sent to Kinesis, 5 little items on the conveyor belt that can then be read off by any number of consumers. It's a limited number of consumers, up to about 5 per stream. If you get more consumers than that, 5 per second, you start to run into contention issues. So we can, now that we've got the data up on Kinesis, let's take a look at how do we process the data, right? And with that, again, we'll use Lambda. And we can go look at that Lambda function right now. And unfortunately, these shortcuts are not working, so we will go the long way. So I already uploaded the application called Store Metrics. So we'll look at the details of it in a minute. But what we've done here is we created a Kinesis trigger for the Lambda function. And you can see down here near the bottom of the screen that the talk metrics Kinesis stream is triggering this Lambda function. So what, oh good, we didn't lose the screen. What happens is every time a data item gets pushed onto the conveyor belt, this Lambda function gets invoked and is sent a payload of, you can see up here, up to batch size, up to 100 items on the belt, which is typically going to be about 5, because I'm only sending, in this small application, 5 metrics every few seconds. So we can now go and see over here in the log files that, and if we go to, say, the last 5 minutes, we can see that every few seconds, we get 5 metrics sent to the Lambda function, and we're logging it out to the console. Excuse me just a minute. I'm going to delve into my backpack for some water. So let's skip back, have a look at the code that was actually sending or receiving the data from the Lambda trigger. Again, this first link, I'm going to skip through real quickly. I guess there are a couple of interesting things here, which I'll just mention real briefly, which is I used Circle CI to, which I actually believe there's somebody in the audience who works for Circle. I used Circle to package up the zip file that I upload to Lambda. So here's the configuration file for Circle, and it runs npm install, which is a node packaging application for one of the things it's going to be including is the AWS SDK, any other sort of standard libraries that I need, and then it runs a little script called upload to S3. So this script will package up the node modules and all of the code, put it into a zip file, and then that zip file is ready to be uploaded to AWS. This is just a little code to do that. It copies the code to S3. Let's see, and the rest is not particularly interesting. So I'll scroll through that. For the people on video, can watch that very carefully. Now, this step is actually somewhat interesting. You can see when I first put in the scaffolding for this, I had it going to West 2. Turns out I wanted to have the code stored in the East 1 region on AWS, because West 2 is actually where we run all our production code. It turns out we don't have very much. I'm actually using my corporate account for this. Turns out we don't have much on US East 1, so I was able to put all the sample code there and leave it nice and clean. So when I took this from my sample code from work, I neglected to get the region correct. So I just corrected the region. And it turns out there's only 4 lines of code that are actually interesting to handle getting the data from Kinesis and then printing it out to the console. And I already gave you the overview of what that looks like in the logs. When you log to the console, in Lambda, it automatically sends those to CloudWatch. So there's just an entry function which gets an event and a few other bits of context, and the event is just those data items that have been picked off the end of the conveyor belt. And that's it. So that's great. Now we've logged those to the console, which we can't get actually. So we want to say, how do we actually get this into our DynamoDB database? DynamoDB is basically a key value store. So how are we going to get this data into Dynamo? Well, let's see. So when I was writing this, I needed to run it locally, right? So because do some tests. So what I did is I ran the code on Lambda and printed out exactly what the data was that was coming into an event. And I copied that down locally so that I would have a sample event that I could then run through locally as I was developing. How do I munge this event into the format so that I can push it into Dynamo? So this is just my little test harness I call development.js. And you can see I construct an event, which is just a couple of metrics from when I first developed this. And you can see that the event source here is Kinesis, region US East, as we expect. And the data is encoded, and you'll see that's one of the steps we do is to decode that, and the arrival time is a Unix timestamp. So that's just a test harness that was really useful for developing. The actual code that's run is much simpler. You see, it fits actually onto just one screen. So replace again, here is the console line that we used to have, printing the data out to the console. Instead, what we're going to do now is take the records. Let's see, process data. Process data. Also, wait, log to console. Okay. Yeah. A little bit, let's see, unpack the console. Okay, I'm sorry. This is actually, again, just logging to the console, just processing the data and logging it to the console. The previous step was logging the unpackaged data to the console. This unpackages this raw data and sends it to the console. The next step is actually writing it to DynamoDB. And here is where we take the data and put it into the format that Dynamo expects. We have Dynamo, one of the commands that you send to Dynamo is a put request. You'll notice this is, again, the command just is a JavaScript object. We say put request item, and we've read this item off of, or the event that came through from Kinesis. Create these 5 different, essentially, columns or values that'll be stored in DynamoDB. There's a limit of 25 per request, so we chunk it up into bits of 25, and then go across all of these chunks of 25 and call DynamoDB write. So that's, now we've got all of the data, hit Kinesis, ran through Lambda, and are now being written into Dynamo. Any questions so far? Very good. Either it's completely confusing or completely clear. So hopefully some of both. I also promised that I'd talk about Athena, which is it's a database based off of S3. So it's a flat file database, essentially based off of S3. And the way that I populate the data is really actually quite easy, because when I wrote the gather application here that's still sending metrics up, I put the data in such a format that when we use a technology called Kinesis Firehose to write to S3, the data is in exactly the format that Athena can then read the data from S3 and access it, give you SQL access to the data. So if we go back to the Kinesis dashboard and look at the data Firehose, we can create what's called a delivery stream. You can see here I've already created Talk Firehose, and it's been running for the last day or so. So we'll create this sample delivery stream. And for Firehose, what it does is it takes data from one source and then writes it to another with optional transformation. So the source is going to be a Kinesis stream, which would, in this case, would be the talk metrics stream. So it's going to take the data off of the talk metrics conveyor belt as it's coming on, and as we'll see on the next screen, you can enable, if you enable transformation, you can have it call a Lambda function and change the format of the data. I was clever enough when I wrote this to put the data into the format such that I needed no data transformation. I skipped over this, I think, this particular step, this adding a carriage return. Turns out when I originally was sending those, the data up to Kinesis, I was sending the data without a trailing carriage return, and Athena requires that trailing carriage return in order to read the JSON records correctly. So once I added that, I didn't have to do the transformation. Thankfully, I wasn't in production, so I didn't have to worry about that. But to be honest, at Machine Metrics, we do use this technology, and our data as coming through on our primary stream is not in the right format to be written directly to S3. So we do have a transformation process where it goes through and it adds the carriage returns and sort of formats the data a little bit differently than is coming through the pipe. So it's a really very flexible and useful feature that thankfully I didn't have to do for this in this step. So I don't need that, so we'll go on. And then you have several destinations. You can send it to Redshift, Elasticsearch, or Splunk. I just sent it to S3. I selected a bucket and a prefix, and I would be done. So the Firehose is sending all of the data S3. And if we go over to Athena, I've created a table called Talk Metrics off of this, based on this stream, or these paths in S3. We're 2 bits to that. One is creating the table, which this looks a little arcane, but when I first created this create table, it was created automatically for me, this code, by using Amazon Glue. It has a feature where you say, here's the table and here's the here's the S3 bucket and prefix. Go through and figure out what the data looks like, and it basically created this this for me. So once we get the table created, which is a little bit arcane, the one thing that Glue doesn't do out of the box is, at least with the way the Firehose creates the data, is it doesn't partition, it doesn't find the partitions correctly. So I have to manually go through and create the partitions, because every hour, Firehose is creating a new prefix. So you can see here on line 3 on March 17th UTC, at 10 hour, there was a this prefix and that having that partition information, and it just goes through, and I created a partition. You can even go into the future with this, which is quite handy. So we created a day's worth of partitions, one for every hour. And now when we go over to Athena, we can do something like select, year, month, day, and hour, and say count how many metrics were sent during each of those, and we'll group by year, month, day, hour, ordered by 1, 2, 3, 4. Oh, we should say from a table, right? Default. Honestly, I did prepare this ahead of time, but I lost context when I rebooted, so I'm doing this bit a little bit on the fly. And there's the data. You can see that it's currently 1900 UTC. This is my favorite utility. Can you guys see that up there? Yeah. It's called UTC menu clock. It shows UTC time, which is just my favorite thing. So it's UTC 1900. You can see there's a bunch of metrics. At 1800 and 1900, I turned this on during the last talk after taking a break for about 4 hours because I was worried about my laptop battery, so I didn't leave this running for very long. So you can see there's a gap in the data that I was sending. Real useful way to get an overview of the data. You can get summaries. You can see real easy. We can. I showed this earlier. You can see a preview of what all the metrics are that are sent, have been sent. These are actually all of the queries. It's kind of cool. Are stored in history, which you can then just click on one of those and pull it right back up. Oh, you can see my error is even logged there, which is really so useful. If we go to this one, you can see we can also download the results as CSV. All the results are just stored in S3. And believe it or not, I think I'm actually out of time. Any questions?
So this talking about Kinesis consumers, it seems like you had 2 consumers in the game, and that was fine. They were able to do the same events. All right? One was Firehose and one was.
That's correct. Absolutely. Yeah. Yes, that's right. And 2 consumers is fine. Up to 4 or 5 is good. What we found is that if you use sort of the automatic consumers of like Firehose or Lambda, they fire once a second or so, and there's really no way to control that. They're no doubt using something called the KCL under the hood, which gives you a lot finer control of that. You can like go out further along the conveyor belt. You don't have to just stay at the tip. But these services, the Lambda triggers in particular, and Firehose are always running right at the tip. And they don't really like falling behind.
The idea is each consumer will receive one and only one like copy of a given record and then
Exactly right. And
you get two lands, they each get a call, same data.
exactly right. Not necessarily batched in the same way, but exactly, the same data. And really, the part of the motivation for why you would want to use Kinesis is, imagine you're shipping a new Lambda function, and it hasn't a bug in it. Well, it turns out as long as you throw an error when that bug happens, Kinesis will keep retrying for up to 24 hours. That same record, it's like, okay, this record has not been processed. So on the one hand, you get kind of stuck, right? But on the other hand, you lose no data. And moreover, all of your providers are continually able to send to that stream, even though you've borked your processing on the back end. They don't have to know that. The conveyor belt is happily running along. Your spot on the conveyor belt is moving slowly out towards that 24-hour marker, but you have the confidence in AWS Kinesis reliability that your providers are going to be able to continue streaming their data, no matter how badly you screw up your code on the back end. So that reliability is really nice, that we don't have to worry about keeping up a fleet of servers, having redundancy across multiple availability zones, or any of this. It's all, we can just rely to a really large degree on Kinesis and AWS infrastructure for that redundancy, that sort of reliability.
So would you not use Kinesis for persistence the way you might use Kafka?
I don't know about Kafka in particular. Yeah, but you cannot use Kinesis for eternal data. If we go back to the Kinesis console here, when you create a Kinesis stream, let's see, number of shards, one shard. There is a way to get more than 24 hours up to, oh, here we go. No. Oh, there's a side conversation going there. No, yeah. So you can get, I think, up to 72 hours, but there's no way to have a Kinesis stream store its data for forever. Kinesis Firehose is about the best you can get for storing the data persistently. Yeah.
Why wouldn't you just use a Raspberry Pi and wget or curl and put your little values in a URL string and then receive them on the Pi and store them in MySQL? Maybe this is an obvious question, but I'm watching your talk and I think, why would I do this way?
Well, if you had tens of thousands of machines sending you data, the Raspberry Pi and MySQL are probably going to fall over, right? So that, whereas this scales to probably hundreds of thousands easily, many providers. So that I think it's a very valid point that this is overkill for a small project. But if you've got a huge amount of data and you want it to be able to scale arbitrarily,
Every Android cell phone is going to send you data.
That's right. Then this becomes a useful way to scale. Because I didn't go into this too much, but the Kinesis streams can be sharded such that they scale, and then each shard would invoke a separate Lambda function. So you have data going basically in parallel, and then getting processed in parallel as well across multiple Lambda functions. Yeah.
Is Athena able to construct databases from content that is outside of S3?
I don't believe so. I think Athena is entirely runs off S3. Yeah. Yeah, I will say one interesting thing about the way the data is stored here in S3 off of Firehose is that there's something called a Redshift spectrum, which does have can also access the data. So you can access this data not only through Athena, but also directly from Redshift without actually loading the data into Redshift itself. So a little side note about accessing the S3 data. Yeah?
Is it possible to maintain the ordering of events between shards?
I don't believe so. Yeah, I believe that they each are processed independently. And certainly I've seen it where we have one shard get stuck and the others just keep processing. So yeah, I don't believe that that's possible.
Can the sender determine which shard they send to, or is that?
Say that again?
Can the sender pick a shard that they go to, or is that automated?
No, you can't pick a shard. It's based on the partition key. And that's fairly easy to figure out. I think it's a hash of the partition key mod the number of shards, something like that. So it's not a particular secret what that special sauce is, but you typically don't really choose your shard. You just you pick a partition key that's varied enough that you get the data spread out evenly across all your shards. You do want to make sure that you don't have a hot key, which is pretty important. Yeah.
How do you find the performance of Athena as a way to pull data? Function worthy? Is it?
It's great for a data scientist, to be honest. We have at this point a few months worth of data in Athena. We started streaming into Firehose back middle of last year, late last year. Data scientist loves it. It takes on the order of a few seconds to parse through several mini gigabytes of data. As far as powering a front end, it's probably a little slower than you would like. That's why you would probably be using something like Dynamo or Postgres if you wanted to have real-time access to the data. But for back-end analytics, data mining type operations, having all of the data available in a database or a data warehouse is super useful. For me, the jury's still out on whether Athena or Redshift is a better choice for that data warehouse. Athena's kind of super easy because you just dump it in S3. One reason that we did go with Athena is that we're hoping, and that performance will be good enough for some of our front end purposes. For example, if somebody wants to go back and say, can you give me data from last week or last month, and they're willing to wait a few seconds for that, then Athena will be fast enough. And more importantly, if we have dozens and dozens of users hitting that at the same time, it scales perfectly fine. We don't have to worry about that. We don't have to worry about a Redshift cluster getting hit from the front end. So that's kind of why we're going with Athena. It's just we don't want to get burned if we do want to expose this to end users. Getting burned with Redshift. So that's one of the reasons we're going with Athena. Currently, our data is in JSON, compressed JSON, which means that Athena has to read through the entire file to get any data. Real soon now, I expect we'll be doing a post-processing step where we take the JSON and convert it to a format called Parquet, which is a column store format for flat files. And then Athena can only read that part of the file that it needs to get the data that you're querying for. And Parquet is also compressed. It uses, I saw an interesting talk on Parquet. It uses much the same sort of ideas that you see in Redshift, just in flat files. So the performance is about 10 times that of the compressed JSON. So I think if you use Parquet format, then the performance of Athena starts to get close to what you might find acceptable if you're willing to wait, say, a second or two for data to come back.
Question.
Yeah.
Do you have any experience with running elastic MapReduce with Hive queries? How Athena compares to that?
I do not. Yeah. Although I suspect I will be doing using EMR to do the transformation from JSON to Parquet, because that seems to be the only way I could find easily to do it. I don't. It's funny that there doesn't seem to be a whole lot of support for writing Parquet format, which you would think would be easy, but as far as I could tell, it's not that easy. You need to use Spark, and that's like, okay, I guess I'll use Spark.
I was a little disappointed about the manual partitioning of the S3 buckets for. Can you talk? I mean, it seems odd that it'd be not something that can be derived. I mean, clearly it's a computation like the key of this.
You would think, right? There is something called Amazon Glue that's supposed to do this, right? It's supposed to go and find your data and figure out the partitions. And it seems like it's a very natural partitioning scheme. If we go over to S3.
It seems like it's a natural partition.
Right, exactly. Let's see, I believe it's in here. Right, and Firehose metrics, and then it's just year, month, day. All right, whoops, why do we not have any data in there? Year, month, day, hour. Why have no data? Well, that's interesting. There's a 3/17. Oh, day, hour. You would think that any sort of clever crawler would see, oh, look, these are the partitions, but it doesn't quite pick that out. Maybe I'm missing something. Maybe there's an automated tool to do this. I found it easier. What I had just ended up doing was writing a little Lambda function that every 6 hours hits Athena and says, create the partitions for the next day, so that they're always getting created out into the future.
I don't know if you can use that in this context, but in Hive there's a recover partitions, which will analyze what data is in S3 and automatically create any missing partitions.
There is something like that actually built in right into Athena. I forget how to get there. When you create a new table, it says there's a command that says go and recover the partitions, which sounds very much like what you would want. You run that and it doesn't actually find them. So it's like, I think if you put like year equals 2018, month equals 3, day equals 17 as part of the path, it can figure that out. But Firehose gives you no capability to add those text prefixes. So this seems to be a little bit of a disconnect between the technologies there. I could be missing something, but I haven't been able to sort that out. Yeah. Right.
But it may have to do with the way that the position is.
Yeah. All right, thanks everybody. I think I'm supposed to wrap it up and give time to the next presenter. Appreciate your attention.